Before I work this problem, I'm going to talk a little bit more about the negation of a biconditional statement. If you recall from the biconditional table, a biconditional statement is only true when both P and Q are the same. Either they're both true or they're both false. In any other case, that is, if one is true and the other is false, then the statement has to be false. And that makes sense because remember, when you have P if and only if Q, that means that the two statements are logically equivalent, which means that their truth values will have to be the same. So either they're both true or they're both false. Well, let's look at the negation of this statement. Not P if and only if Q is going to be false, true, true, false. So let's see if there's another statement that this is equivalent to. In a previous, in my PowerPoint slides and in your textbook, it says that this statement here, not P if and only if Q, is equivalent to P and not Q, or Q and not P. Well, let's look at that. Why is that true? If you recall the negation of a biconditional statement, P implies Q, is going to be P and not Q. So this is equivalent to the negation of P implies Q. And this is the negation of Q implies P. So using De Morgan's law, I know that this is equivalent to the negation of P implies Q and Q implies P. Well, P implies Q and Q implies P is just P if and only if Q. So what we have here is the negation of P if and only if Q. So we're going to, that's one way to write the proof. I used De Morgan's law to show that. Well, let's use a truth table to verify that what I'm saying is correct. So I'm trying to see if this column, this last column that I wrote here, is equivalent to the statement P and not Q, or Q and not P. And here it would be helpful to number my columns in the order in which I do it. I'm not going to write a column for every little piece. I don't have enough space for that. So I'm going to call this column 1 and 2, and then I'm going to come back and get this as 3. So column 1 is P, that's going to be true, true, false, false. Not Q is false, true, false, true. Joining those using and, false, true, false, false. Then I'm going to go over here. This would be 4, 5, and then 6. And then lastly, I'm going to come back and get column 7, which will be the final column, and I'm going to compare that with this column right here. So column 4, Q is true, false, true, false. Not P is false, false, true, true. Joining these using AND, false, false, true, false. So I'm now going to look at this column 3 and column 6, compare them using, or join them I should say, using the word or. False or false is false, true or false is true, false or true is true, false or false is false. Notice our two boxed columns are identical, which means that the two statements are equivalent. We're now ready to work problem 2.66. In this problem, they're asking us for which biconditional is its negation the following. In other words, they give us the negation of a biconditional statement and they want us to find the original biconditional statement. So we know that the negation of a biconditional statement is equivalent to the statement P and not Q. Or Q and not P. So let's see what we have here. The first statement says n cubed, well the statement says n cubed and 7n plus 2 are odd, or n cubed and 7n plus 2 are even. So the two statements I have here are, if I let P be the statement n cubed is odd, and if I let Q, well, let's look there. Then let's let not Q be the statement 7n plus 2 is odd. Okay, so that would be this is odd and this is odd. Well, that follows because this would be where my or is. So what we have here is P and not Q. And then over here I have or. Well, this is saying n cubed is even. N cubed is even, so that would be not P. And 7n plus 2 is even. So not P, let me put that here, is n cubed is even. And Q is going to be 7n plus 2 is odd. So in symbols, the rest of it is not P and Q. And we know that the commutative property holds when we're dealing with conjunctions. And so that would be equivalent to what we had up here. Well, so what would our original statement be? Because obviously this is the negation. This is equivalent to not P if and only if Q. Well, what would my original statement be? P if and only if Q is the statement n cubed is odd if and only if 7n plus 2 is odd.